I'd like to start off by saying this video is made with knowledge that probably is either incomplete or might even be incorrect. I'm just showing you what I know and what my personal opinions and beliefs on why this does what it does. And so if anyone out there knows why NSI and similar companies do this, please tell me. I will be happy to change my opinion once I learn the facts. But I will just show you what I know. So, you have your NSI, a DDS 6000 digital dimmer system. Looks like a pretty run-of-the-mill 4-channel, 1,200 watt dimmer pack. And let's look at the back of it. It has a weird looking connector that is their way. One of their ways of controlling it is you have ground on the bottom, and then you can then put up to 10 volts on each pin, and on a scale of 0 to 10 volts, it controls 0 to 100% on each channel. That's cool. You have your standard dip switches that can switch it from automatic to control, or controlled through this or this. You have your fuses, resettable fuse, which is pretty nice. I've always wanted to have something that rather than blowing your permanent fuses, you can actually just reset it. Haven't tested that at all yet, but what I have tested is this. A lot of people might recognize these as, theoretically, DMX converters, or DMX ports, or maybe even XLR if you're more towards the audio. I know I was when I started. And so let's see what happens when I plug a DMX chip into this thing. This is a RS485 to TTL. Basically, this is a DMX chip for an Arduino. This is what I now use to test any hardware I get, so that rather than burning out my really expensive hardware, I burn out this $20 chip that I can get on Amazon. I actually think it's like 20 bucks for a pack of 20. Before I plug it in, just to prove to you that there's nothing weird going on. I don't have the hardware right now to show that this works, but I do. What I do show you, or what I will show you, is if I take this temperature gun, you see it's about, what, 75, it's room temperature right now. However, if I plug this standard, just pretend this is a DMX Sushi or something like that, or Sushi DMX converter, or similar mini DMX converter. Notice nothing happens here, which is fine. This is not getting any signal to do anything. But if I was to measure the temperature on this again, you try to get it just the right, there you go. 125 degrees in a couple parts of it. Notice it reads the maximum temperature on the bottom. Let me do it again, just to prove that was not a fluke. There it goes. And this temperature gun is not that good. I got it from Harbor Freight for like $9, but it's still reading an absurdly high temperature on this. Why? Well, anyone who knows much about DMX probably knows that DMX signals are ideally anywhere between 1 to 3 volts. I have had a dying DMX Sushi converter output 5 volts, but even then it had almost no current behind it, so it couldn't do much. But if I measure this the power coming out on on what is supposedly a DMX input or output, you have 14 and a quarter volts. And if I was to unplug the DMX converter, bumps up to around 14.7. That's not a glitch. That's not a hardware issue. That is not a fluke. That is exactly as it's designed to do. Let me show you something on the other one, because I have 2 of these. One of them is still assembled. The other one I tore apart to see why it was doing this. Then I finally found the manual to it, and I realized why it was doing that. So, this NSI decided to be, I'm just going to call them a bad apple for now, and make this standard connector head proprietary. Rather than use DMX, which would be, I don't remember the exact orientation, but essentially ground, and then data plus, data minus, so you can have high-speed two-way communication if necessary. They decided to make it so that your dimmer pack powers your light board, so that you don't have to plug your light board into power, which I guess might reduce interference, might increase efficiency, help with cable management. That's about it, because the disadvantages of that is, A, you then have to use hardware that uses both of these, or that uses exclusively multiplex communication the way they did it. And then you also have to make sure you don't plug it into a sound system, because sound systems can handle up to like 12 volts, if I remember correctly. 15 volts would cook that. 15 volts cooked this. Well, actually, this is the new version of it. I've just removed the casing. This is a DMX sushi, or a sushi DMX converter that like you plug into a computer to turn your computer into a lighting console. Yeah, I cooked it by putting it on this because I didn't know. And not many people, and no one, and people who are new to the field might think, oh, this is just a normal dimmer pack. I know how they work. And plug it in and then burn out their converter. And thank goodness I burned out a converter and not my $3,000 light board. Now, okay, proprietary nature, or maybe even better, let's play devil's advocate and say that maybe this was the only method. DMX may not have been around at the time, or maybe multiplex was the standard. Okay, that's a legit argument. Maybe multiplex was the standard. I don't think so. I don't think multiplex was the standard, or at least was the only way of doing it. Because, of course, you still have the analog control, and this company, in the manual, references the fact that you should never plug a DMX system into this, or a sound system into this, because of that 15-volt power. And rather than selling this as DMX controlled, they have two options for you if you want to use DMX. A usually $1,000 box about this big that you stick on the end of this and it turns it into DMX. Or, and I got it from B&H Photo, it hasn't arrived yet, but paid $120 for, if I'm just guessing, because all the B&H Photo has as like its a listing is just literally a 5-pin DMX connector that I'm assuming will sit right here. Yeah, because of course, it's not like they didn't have room on the faceplate to put it, because they machined a hole there and there. And I can't get the other one out. But they machined holes that are just big enough for a XLR connector. And I'm assuming the only reason it's not over here is because they have a power cable. And I guess that's fair, but they probably could have moved this one over here and then moved these two down to get more space, and that's neither here nor there. But what I'm also assuming is in that kit from B&H Photo, the $120 kit, including shipping, that apparently I don't think it's made anymore, because B&H said they never know if they're going to get restocked. So I only bought one of them, despite the fact I have two kits, and hopefully a follow-up to this video is part of me reverse engineering that kit, so that I can show you how to make it at a much cheaper cost if you have something like this. But let's take a look on the motherboard. You know that I've removed nothing from the motherboard. I've removed the control wings and stuff, but everything that was connected to the motherboard is still connected. And you'll see three things. There are two connectors, there are two 5-pin connectors, as if maybe two pins for 5-pin DMX connectors, and then an 8-pin integrated circuit slot. Now, what could that 8-pin integrated circuit chip be used for? It could be used for, most likely, that, or at least a version of this. This is a chip that I've seen on every single thing that uses DMX, and I'm guessing it's just the standard way of doing DMX. It's on my sushi adapter, and a version of it is even on my Arduino adapter. It's that squarish one right there. Just note that it's thinner because it's surface mounted and it's soldered down and it's tiny, just so that it could fit on this board. And what do you know? You could probably put one right there. And if you get the orientation right, I'm guessing that you then have to probably change settings on these switches. I haven't messed around with them yet. But then you can use this, meaning this pack was built with the intention of using DMX, but not letting you access it. This pack, again, could have used DMX because there's a slot that I'm assuming is for a DMX chip, and there are two 5-pin connectors for your 5-pin DMX converters, or cables, or rather. Dip switches, just like on a DMX pack. Now let me backtrack a little bit and why I call them a bad apple. That's not just me putting a funny word in there that might sound like something else. No, that's me literally saying they're trying to be like Apple was and still is, but doing a terrible job at it. Because, you know, every latest Apple product has something proprietary about it that means it either A, doesn't work with anything else Apple has made in the past, or B, doesn't work with anything else. But at least when Apple does that, there are two options that prevent you from using it. There's either A, and this is the usual option, is that the connector literally doesn't fit. If you look on the two different versions of the MagSafe MacBook charger, yeah, they might have different voltages and different versions of it, but the reality of it is you can't plug a MagSafe 1 charger into a MagSafe 2 laptop, and you can't put a MagSafe 2 into a MagSafe 1 without one of those adapters. And you also, like on a USB-C MacBook, I can't plug in this DMX Sushi converter without a special adapter. That's made by Apple. But at least if I try to hardwire this into the USB-C port by hand, most likely because it doesn't have the MFI or made for Apple, or MFA made for Apple, or I guess it's MFI because it is made for iPhone. I don't know what the equivalent is on the MacBook. But at least if they do that, most of the time the MacBook's just going to say unrecognized device and turn off that USB port. It's not going to use a standard connector and fry my converter. 15 volts down a 3-volt data line. And then having the audacity to sell you probably $1,000 converter that, if I remember correctly, only works per pack. And that $120 chip from B&H, you only get one of those, and one pack or one kit gives you the parts needed for one pack. I could rant about this for days, but yeah. If anyone knows why they did this, and it's not because they are greedy bad apples, please feel free to let me know in the comments, or just tell me, I don't know. And in my follow-up video where I explain how to reverse engineer this chip, I will mention and reference that. Thanks for watching, and sorry for the ranty video.